Hello and welcome to Algebra 2, Chapter 7.6, and today we are discussing solving radical equations. So these are equations with a radical sign, and more particularly where the variable is under the radical sign. So to solve a radical equation, you need to isolate the radical expression, that means to get it by itself, and then you're going to undo that radical expression by raising each side to that power. So if it's a square root, we're going to square each side. If it's a cube root, you're going to cube each side. You're undoing that radical. Okay, so here's our first example. 5 minus the fourth root of x equals 0. So you need to get the fourth root of x by itself. So we will start by subtracting 5 from each side. Negative fourth root of x equals negative 5. And we do need to divide by negative 1 to make it a positive fourth root of x equals a positive 5. And then to get rid of that fourth root, we're going to take each side to the fourth power, because that's going to undo that fourth root. And 5 to the fourth power is 625. So x equals 625. There is our answer. Alright, so here's another one. The cube root of x plus 6 equals 12. So we're going to subtract 6 from both sides to get the radical expression by itself. And then to undo a cube root, you cube each side. So x equals 6 to the third power is 216. Just like that. Alright, so what happens if we have a exponent instead of a radical expression? Well, just remember how they're related. So if I divide each side here by 2, I'm going to get x to the 1/4 power equals 4. And you could think about it as the fourth root of x if you would prefer, either way. So over here, it would make sense if we took it to the fourth power. But over here, it also should make sense if we take it to the fourth power, because an exponent to an exponent, you're multiplying, and 1/4 times 4, that just gives you that x. So 4 to the fourth power, no matter how you do it, is 256. So two ways to think about that one. Okay, so what happens if you have two radical expressions? Well, we're really going to hope they're the same index, so these are both square roots. We do need to get one on each side. That's going to be the best bet here. So let's go ahead and move this one to the other side so that they're both positive, because they'll be easier to work with. So we have the square root of 4x plus 28 equals 3 squared root of 2x. And then to undo a square root, we're going to go ahead and square both sides. And remember, we square entire sides. So this becomes 4x plus 28 equals, so here, this is the property, if you have a, b to the mth power, that exponent goes to everything. So it is going to the 3, so we're going to get 9 times, and then it's going to the square root, and so that just becomes 2x, so that we're going to end up with 18x there. And then to solve this for x, we'll just do a little bit of subtracting. 28 equals 14x. If you divide by 14, x equals 2. So something that we haven't brought up really before is the idea of an extraneous solution. And an extraneous solution is a solution that doesn't work. So you've solved it correctly, you've gotten this answer, but when you go to put the answer back in, it's not going to work. And there's two big places where extraneous solutions come in, and one of them is when you're dealing with radicals or roots. So, if you're solving for the square root of x, and you've gotten x equals negative 2, can you put that negative 2 back in? So that's why, that's where this wouldn't work, is because you're going to have a negative under the square root. The other one where you get extraneous solutions is if you're dealing with fractions. And so if you get x equals 0, well, that's not going to work because you can't have a 0 in the denominator. So the two big cases that you have to watch out for extraneous solutions is when you're dealing with radicals and you can't have a negative under a square root, and when you're dealing with fractions and you can't have the bottom equal to 0. So here's a problem that, this could have been in the previous section. We're going to solve this. So we're going to undo the square root by squaring both sides. Key thing is that we're squaring sides. So on the right-hand side, you get 2x plus 28. But on the left-hand side, we have to square this, which means that we are going to have to FOIL. So that is going to be x squared plus 2x, which is 4x, plus 4. So this gives us a quadratic, and we're going to go ahead then and set it equal to 0. So it's a quadratic because we have that squared there. Okay, and then you can solve it by factoring, quadratic formula, completing the square. I'm going to see here if this factors. Thinking 4 and 6, let's do plus 6 minus 4. That gives us a negative 24, positive 2. So that when you solve these by setting each one of them equal to 0, you're going to end up with x equals negative 6 and x equals positive 4, which is great. And you can have two answers here. That is fine. But we need to make sure both of these answers work. So if we come back up to the beginning and we're just going to plug these in to check. So negative 6 plus 2 is the square root of 2 times negative 6 plus 28. So there's negative 4 equals square root of negative 12 plus 28, which is going to be 16, which is going to be 4. So does that work? It does not. So negative 6 did not work. So then we need to check 4. So we're going to have 4 plus 2, square root of 2 times 4 plus 28. And so lots of times you are looking for a negative under the square root. In this case, that first one was equal to a negative. So that answer worked. Okay, so the square root couldn't be equal to a negative is why the first one didn't work there. So let's try one more just to make sure that we got it. So we're going to go ahead and square both sides. So we're going to FOIL. Okay, so that's going to be x squared minus 6x plus 9 equals 4x. Again, we have a quadratic, so you always want to set your quadratic equal to 0. And I'm going to go ahead and see if I can factor. Let's do minus 9 minus 1. Should give us a negative 10. So then x equals 9 and 1. So we get two answers. And if we look up here, and they could both work. So let's see. So if we do 9 minus 3 equals the square root of 4 times 9. So 6 equals the square root of 36. So that one works. Okay. And 1 minus 3 equals the square root of 4 times 1, which is going to be negative 2 equals the square root of 4. That one's not going to work. So 1 does not work. Your only answer here is 9. So something you should always keep in mind is that you do need to look for an extraneous solution, and that's just a solution you get that doesn't work. All right, let me know if you have any questions. Have a great day, and I will see you in class.